So now what I'm going to do is I am going to run the dissolved oxygen test kit. And I'm just going to, has anyone ever run a dissolved oxygen test kit with a titration? So a few of you have. Okay. I like this one because it changes colors, and since I like to talk about oxygen and water together, it's a way to quantify oxygen in water. I like to model gloved and safety glasses, and and the kids too. And it also makes you feel like a real scientist.
I will caution you about putting out too many gloves, because if you don't get ahead of the kids, every kid will come over and put on a pair of gloves, and we run out of gloves really fast. So be prepared for things like that.
And blow them up as balloons.
Yeah. So what I do is I just pick a couple, like two or three kids to help me, and I will do that with you all if anyone wants to come help me. Anyone want to come help me?
Yeah,
Amy, Maxwell.
I encourage you to do it. Just their direction is not hard, but
and I actually might have you guys take two.
Actually dangerous for children.
Actually, they're more if you would eat it, or yeah. So
there are new glasses in there because the old ones are pretty terrible. So you might want to get some.
Don't try and read anything.
The ones have been around like 20 years.
There's various sets of instructions for the kits, and if you haven't run one of these before, feel free to just run it on your own or borrow a test kit if this is something you're interested in. Don't feel like you have to do it the first time with 10 kids standing there.
Do you ever stage them, Francis? I usually have with two kits. I usually have one that's ready to titrate and one that's ready to go from the beginning.
Yeah, I will sometimes. And a lot of times what I'll do is I'll just take one sample and have it ready, and then I'll only do the titration for the rest of it. So I say, so we've talked about temperature, we've talked about oxygen and how cold water can hold more oxygen than warm water. Well, if you're trying to figure out the characteristics and the quality of the water, and you want to figure out and measure the oxygen, how do you measure oxygen? Can you see oxygen? Can you weigh oxygen? Can you take a tape measure to the oxygen? How will you measure oxygen? And no one knows. So I said, well, we are going to do a test here, and it involves chemicals, and we're going to have safety gear on, and we are going to do a test which is going to measure oxygen, because what we are going to do is we're going to find something that the oxygen likes so much, and I call it the oxygen's buddy, and then we're gonna figure out how many buddies of the oxygen are there. And then I have to talk about sample. What's a sample? You go to Costco, do they give you the whole cake? No, they give you a little tiny piece. So we are gonna if we are taking a sample of the creek, what do you think we're gonna do? We're gonna get a little tiny piece. And I say, Maxwell, you're gonna use this bottle, which is glass, to get a tiny piece. And the way we get dissolved oxygen samples, and I sometimes will walk the whole group over, is you don't want to just scoop it off the top, because there might be more oxygen on the top. You put it underneath the surface, and then you turn it upside down under the surface of the water. So you're gonna need to be in a piece of water here that you won't fall in, and you can get the bottle underneath, and then you put the cap on while it's under water, and you don't jam it in, because we need it loose, and because it makes our test book better. So Maxwell, go ahead and do that. And usually we'll all walk over and watch Maxwell do it. Make sure he doesn't fall in, and give him lots of. Yeah, I mean, if they're over 10, they can do it. Yeah. Okay. Perfect, Maxwell. Then we'll come over. Okay. All right. And so I'll have Amy she's going to read the instructions. And have we been doing this? Go ahead and read it out loud.
Rinse and fill the round bottle with sample water from midstream. Stopper the bottle without trapping air bubbles. We just did that.
Right. And we can't do midstream because we're not going to make people wait out.
Okay. Add dissolved oxygen 1 or DO1 powder pillow.
Okay. And I say, read the fine print because you have good eyes.
And DO2 powder pillow.
That's DO1, I think.
Second one is a scope.
This is DO1 and this is DO2.
Okay, so will you pull one of those out, and I'm going to pull one of these out. And a lot of times I'll have them already laying out, but it's actually easier for me to leave it in the envelope because otherwise I'm like, oh wait, which one was this? Okay.
So add 1 and add 2 and restopper the bottle, excluding
He
any
knows
air
how to
bubbles.
do it. Okay.
Drip
I'm gonna
termination
let
figures.
I'm gonna let you do
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 both of
it.
them?
Yeah.
So is it okay that there's some air?
That's what I was going to. Normally I get they fill it
Oh
up.
yeah. Yeah.
We
You
gotta
need
do
to
it
fill
again?
it. Yeah.
Gotta do it
Go ahead and
again?
fill it. No air bubbles at all.
Okay.
Good catch. All right. Thank you. And you can. I usually pass this bottle around and have people make an observation. Did we fill the bottle? What does it look like? And now we can even look at like the color or things like that. All right. So here I'll have to.
Which one's one?
You could put them in at the same time.
Okay, yeah.
Would be good enough. Okay, keep reading that, Amy.
Okay, then restopper the bottle, excluding any air bubbles. Griply firm and shake vigorously.
So, and that's the trick. So if you saw what I did, I just dropped it in, and you don't want to grind the stopper in. And then you want to, when you give this to a kid, you want to make sure you say, just lightly hold your finger on the top, and then shake it up. And hopefully there's not an air bubble in there, at least that you can see. But I say, is there air in the water? Is there air in the water? Did we discuss there was air in the water? Or oxygen? Yes, there is oxygen in the water. And it's incorporated with the air, so there's other things besides just oxygen. And how, there's a lot of kind of time here to talk.
How long does this go for?
Does it look pretty dissolved?
No,
It
not
says
really.
a flock will develop, allowed to settle halfway, then shake and allowed to settle again.
So go ahead and just set it down there for a minute.
A what will develop?
Flock? F-O-L-C.
So flock is short for flocculent, and flocculent is where, so what we just did is we added 2 chemicals, right? One of them is the buddy of oxygen and grabs onto its friend oxygen. So there is a chemical in here now that is grabbing onto all the oxygen molecules. And as it grabs on, it also starts solidifying. That's part of the process. And I do not know, I cannot tell you, I don't have the names of those chemicals memorized. It's written on there though, if you want to know.
You really want to.
But I do know that the way this test works is one of those chemicals is grabbing onto the oxygen because we decided we can't see it, we can't weigh it, we can't measure it with a tape measure, but we're finding a chemical that likes oxygen who is grabbed on. The other thing you always want to do with this station is make sure you keep track of all your trash and not leave any of it laying around.
We have some little garbage bags on the list.
Okay.
Areas.
So, and if people want to come up, you can see what we've got. And a lot of times, this is the first settling of the flock.
So is that sediment?
This is the flock, which means the chemical itself has made a precipitate. And I don't know. Did anyone know the difference between flock and precipitate? It's pretty close.
Yeah, I was just gonna say. I'll look it up though, because I should know that.
They found some friends.
Yeah, the oxygen found some friends, and it's solidifying
Okay,
with them.
so that's actually oxygen, the brown stuff.
No, well, the
And it's-
oxygen
and
is
it's
in
friend.
there. The oxygen is in there, but I'm not going to say if the oxygen is actually the brown part. But the chemicals that we put in with the oxygen, the 2 chemicals have turned brown. So when you look at this, when you see the flock, this precipitate, it was created by the chemical that you put in with the oxygen.
Oxygen and friends.
Oxygen and friends, and the friends helpers, because it's all a mixture. It's like a cocktail.
If I remember correctly, but I'd have to look it up. I think a flocculant would be because you added the chemicals, whereas a precipitate is something that falls out of solution. So it
Naturally.
would be naturally, yeah. So it'd be like, you scoop up and then you
Seawater or
watch
something.
it kind of come out or whatever.
And you bottle. Did we see a sediment or anything? No, we didn't. Okay. So then when you shake it another time, and then that's just to make it mix some more, and then we can still, do some more observations. It's like, oh, the friends are still grabbing on, and then we let it rest a little more, and we can chit chat some more and get ready.
And then we're gonna add DO3 powder pillow.
And that's you, Amy.
Woo!
Here, Maxwell.
Put your glasses down.
Can't
Gonna
see.
demonstrate good too.
So here's a little. So these are these are very hard, and often you wanna give it a little knock. Make sure it's all down there. And
And I think we now have
that doesn't-
scissors in every kit, but the
That doesn't
kits
work.
come
I have
with nail
clippers.
clippers, which are hard for the kids to use.
yeah.
So hopefully we have scissors.
And I believe this one is the sulfuric acid.
Oh, fun.
But
3, it does not say.
doesn't say. Can you read that?
Fantastic.
Yeah. Okay. So then we look again. The flock, the solids have settled down again. And now what we're going to do, we're going to say, have all the oxygen in their buddies been bound together? Now what we want to do is we want to stop that process. No more oxygen grabbing on to other friends or whatever. We don't, because we're now going to start opening the bottle and maybe more oxygen will get in. So we're saying, okay, no more buddying up. Okay, go ahead and dump that in. And sometimes if it's on the neck, I'll do a little tilt and then just go ahead and let it drop in there, and hopefully, yeah,
Still a little sediment.
that's okay. That's okay. And then go ahead and put your finger on and then do a little invert. Oh, that's okay, no problem. And this is why we wear the glasses, in case this little comes out.
The kids always get concerned when they see that stuff splash, like if it gets on them.
Hopefully you wore your play clothes, not your.
Generally, as long as you don't drink it or get it in your eyes.
Yeah.
That's really good.
Go ahead and keep going. You want it. It's going to actually turn fairly clear.
It's going to turn yellow. Well, eventually clear. It's going to turn yellow now, right?
Yeah. So then we can talk
So
about
what's the yellow part.
So that just is the sulfamic acid is doing something to those other chemicals, and it turns yellow. I don't know what. Sorry, but
So
we
can
have
see
to.
it. That's
We
what I
have to
say.
be able to see it, and this is how we're going to do the measurement. I mean, we saw it when it became a solid flock, but what happens is this other chemical is stopping the oxygen buddying process, and this is how we are going to figure out how many oxygen buddies are in there, because now this acid has glommed onto the buddies, and we can actually figure out, we can count how many of the acids, the buddies are in there.
That's good.
That's good. So now, and you can go ahead and walk it around, show everyone. We can talk about describing it, what it looks like. The flock is gone. The oxygen has grabbed onto the buddies, and then this other chemical has grabbed onto that buddy. And go ahead and read, where are we at?
And fill the small plastic tube with this sample and pour into the square bottle.
Go ahead. Ready?
Yeah.
So what you want to do, so now we're actually going to take a sample of the sample.
How do I
So,
do this?
so how you're going to do this is you're actually going to take the lid off. Here, you
Oh,
can
I'm gonna
hold
pour
it.
I'm gonna pour it.
Yeah, you're going to pour it off, not in front, not on your lap. and you're gonna do it till it tops it up all the way, like that, just like that. And then you're gonna, what I do is I do this and then this. Because it's too hard to take that little tube and there's too much surface pressure to, yeah.
Sometimes there's a little surface tension, it doesn't come right out.
Yeah.
That kind of causes the kids a little.
So now you can walk that around and show people, okay, this is the sample of the sample. This is, you know, what color. We talk about the color is important because what we're going to do is going to change the color. And now this is the this is the solution that sticks. So if you are running out of time, you can this is what's called the titration part, where we're going to figure out how many of those buddies of buddies are in there. And you can just keep reusing this. So you don't have to do the whole grabbing from the stream if you feel like you don't want to. But however you want to do it, either way.
It kind of sometimes is class dependent. Sometimes it works where your class can, you know, focus on one. Sometimes you have kids all across the board, so you have to split up activities a little. So sometimes I'll do it where I'll have some kids just work on the color change while the other kids are working on bringing it to that point. And so there should be 2 dissolved oxygen kits in each, I hope. If not, there should. So
Read it. So, and we're gonna stand. Oh, let's see. Show the camera there, Maxwell. Woohoo!
And not that it necessarily matters for most classes, but when we actually did analysis of dissolved oxygen in the lab, we did a version of this test that was lab-based, so it was the exact same procedure essentially.
Right.
Same chemicals, we used a little bit different of to drip them in and make the change. But so one of the things that, depending on the class, I like to say is I'm a water scientist. They say you'll never use your chemistry for anything. Well, I use my chemistry all the time. So.
And if you want to learn more about this is the Winkler titration method to determine dissolved oxygen. And it says it on the box too. Okay, so what's next?
Add sodium thiosulfate solution by drop, counting the drops and swirling to mix each time.
Okay.
And when the sample is entirely clear, the number of drops is the parts per million of dissolved oxygen.
Right. And sometimes, well, we're going to do that, and I always get the group to count. So Maxwell, hold it out in front of you. And so what I do is I have the group count with me. We do 1 and do a little swirly swirly. Any change? Does it look the same?
Same.
2, swirly swirly.
Starting to change.
What's it changing like?
Smoothing
What's it
its
look?
color.
3. All right. And sometimes at some point I'll walk it around. Does it looking different?
Getting lighter.
Okay. 4. Okay. And so sometimes I ask, what do you think? Is it clear? And what you can also do is you can pass titrate it. So if we get to this point where, kids can look, if you add 1 more, you can be certain. Okay. And how about now? Is it clearer?
Yeah.
That's always what happens. You get there, you think it's clear, and then you add that 1 more. It's like, oh, now it's clear.
Got 4 or 5.
If you go
That was 5. Yes.
Mm-hmm.
If you go way over, does anything happen, or does it? Just
No,
stay
it won't
clear?
get clearer. So you always know once you get to that point where it's like, bing. It's like, okay, because I can add another one and you won't get there.
You can add 10 more and it won't change. The biggest issue is once you get that change, that's the amount of dissolved oxygen in the stream. So we're finding a level of 5, so 5 parts per million, 5 kilograms per liter. And I've had kids who have like, oh yeah, I got 34. It's like, Bear Creek will be lower than the Rogue River or the Applegate. You're probably looking somewhere between like 6 and 12. I don't think I've ever seen dissolved oxygen above like 14 on the road. It's really cool and fun.
But you can talk, the difference between baking soda and vinegar, and there's a range, and it goes from 0 to 14, and neutral, thank you, is 7. And then you can see this shows the pH preferences of these are macroinvertebrates and plants too. There's a plant in there. So a couple plants. So if they've already been to the macroinvertebrates, they can say, okay, who has, what are the animals that have a very narrow range of pH they like? I'll just pass these around as one tool. And then when we were talking about temperature, oh, thank you. I have a similar table here about what the preferred optimal temperature for different. These are all salmonids at different age classes, different life. Okay, diseases and bacteria thrive. You can do a lot just with this table if you want to talk just about temperature and who likes cold water, who is harmed by warm water, who thrives on warm water. Diseases and bacteria thrive. Cold water loving fish don't. So pass that along.
And if you want to get some again, depending on the class, if you want to get more technical, you can actually give them water quality limits for temperature: 18 degrees, 64 degrees Fahrenheit, 18
right.
Celsius. So when they go and they actually measure the water, you can say, okay, what did you get? And is it healthy for fish or not? The same with dissolved oxygen. So actually give them numbers and then relate it back to here.
And so here we have measured, because we were able to do the chemical test to measure the chemical that was attached to the oxygen molecules, we determined an exact number of oxygen milligrams per liter or parts per million. And that gets a little confusing. Those two units are equivalent. Sometimes I'll talk about milligrams per liter. You have, in 1 liter, you have 1,000 milligrams, right? And so if you have, what did we find? What was the number we got? 5 milligrams per liter. So if you think of a liter, which is 1,000 milligrams pop bottle, if you smashed all the oxygen, it would take up 5 of the 1,000 of that liter. And so then we can look at this table here, or this is a bar, I guess this is a bar graph. But you can see 5 on here. And it's at the far end of the range for survivability for these things. So carp can they can do fine with just 2 milligrams per liter oxygen. So does that mean they can survive on less oxygen than salmon? Yes. Salmon need more oxygen. And where do we see the egg and if they've already been to their salmon station, they've talked about the egg and the 11 incubation. How much oxygen they need? Wow, they need like 11 milligrams of oxygen. Could the egg survive on 5 milligrams of oxygen in this stream right now? No, they couldn't. The eggs would not survive. And the good news is, though, here we are in September, and there are no eggs in there. The eggs will be laid. If you've been to the salmon station, you talk about how the eggs of salmon are going to be laid more in end of September and October. Hopefully things are going to get cooler. We're going to get a rainstorm this weekend, and that will bring more water and cooler temperatures. So hopefully by the time we get the salmon in here and actually laying their eggs, you can get that oxygen levels into the 11 and 12 and 13 milligrams per liter that will allow those salmon eggs to survive. Right now, we still have other kinds of animals living in there. So mayflies, stoneflies, they can survive just fine on like 4.5 milligrams per liter of oxygen. So they're doing those macroinvertebrates. A lot of them are just fine at this. If you want to get kids actually writing with like the dry erase, and they can record the water temperature, they can record the air temperature, they can record the dissolved oxygen. There is a test for pH.
There is a turbidity meter, but I got to see if it's working. It wasn't working, so there's no salinity, but there was a turbidity meter.
So again, this is more. These kits are just a lot of tools, and if you want to dig into, it really helps. Like I have my shtick I like to do with the temperature and the oxygen and the game, and I do this one test. And other people like to do other things. Other people do get into, the pH test is easy. It's just you fill a tube with water, you put some solution in, then you do a color match. And then you can talk about that same graphic, talk about that as another aspect of water quality and what impacts that. The other thing, when we're talking about water quality, is what impacts water quality. Is it not just riparian, but what kinds of things are coming into the water? So I come from stormwater, so I spend a lot of time talking about stormwater. Lazy Creek flows right through town, and if kids are local, it goes right by the Rogue Regional Medical Center, and so these are kids' neighborhoods. People know where Barnett is. They know where Larson Creek is, and goes by Orchard Hill School. And all of our streets drain in to the creeks. When you walk along the sidewalk and you see those holes in the gutter, those go straight to a pipe, which dumps into one of these creeks. So what kind of things can be on? So I do a whole shtick because I'm a stormwater person. What kind of things do we have out in our landscapes that can end up in the creek? What are things in parking lots? What are things in your yard? Have you ever been on the turf and seen all the pellets of fertilizer all over the sidewalk? So do you think fertilizer is something that's good for fish and the invertebrates in here? So I spend a lot of time talking about stormwater because that's what I need to talk about.
For me, the stormwater part of it is depending on the site. Like McGregor is not quite a good site to talk stormwater. And the pH, if anybody wants to try it, it's a very easy test, but the kids love the test because it's a matching color. So
you've got a bunch of them in there too.
I always do the pH test, and then one thing we've kind of added, like Amy was asking, is what we have. There's pH meters. So again, depending on the students, and there's also temperature measures. Have them experiment with different methods of what did you get from using the color wheel versus using a meter? Is it the same? Is it close? Why are they different? I like this site for water quality because one thing that I'll do is I usually have kids do a little bit more activities. I'm not quite as an animated talker as Francis is, so I rely a little bit more on the tools. But here we have Lazy Creek, here we have Bear Creek, so you have two different water sources, and they have very different water quality. So you can have, a group do Lazy, a group do Bear, see what, the changes are. One thing I will use this is I'll divide the kids up, have somebody want to be the recorder, somebody does dissolved oxygen, somebody will do the pH, and I'll actually try to keep some track of this, what did the last class get? And, so give them an illustration of how things change throughout the day. Because, morning class, obviously temperature will probably be a lot lower, dissolved oxygen will be higher, and it will change a little throughout the day. I'll do not really sneaky, but air temperature, set up air temperature and water temperature, and set up two different stations where actually put a thermometer in the shade, and put a thermometer in the sun, and it's should be obvious why there's a big difference, but it isn't always. So again, a lot of different things you can do depending on what you want to reinforce, what the level of your kids are. For me, doing younger kids, a little bit more on demonstration, a little bit more on explanation. Older kids, again, that middle schoolers, again, I've been high schoolers too, much more capable of this is how you do it, go do it. So
thank you. So is there anyone else have anything to add about water quality? So there's all these waste containers. They can go into get flushed down a toilet or into a sink that goes to a water treatment plant. You might not want to put it down to a septic system, but it's so dilute, I don't think it's an issue. But that's what EQ tells us to do with this. And so